Hello guys, and welcome to the 18th video of our Python playlist. And in this video we will discuss recursion. Recursion is a type of function that calls itself. It means that in the body of that function we are calling that function. Like for example, we have function def. S is a function and we have an argument in it n. So what is happening that inside this function, in a specific condition, this s function is again called by using the return statement. So in the recursive function, we have several things that we have to make sure. First is that how we should be calling the recursive function, and what is the base case. So, in simple words, what is a base case? A base case is, you can say, the answer that we know, is the answer that we know, any value that we know about a scenario. So, if we talk about a function that is calculating the factorial, for example, right? So, what will basically happen that if I write a factorial function over here, so if I talk about this factorial function and I provide n in it as the argument, a parameter, and I have a variable answer is equal to 1. So what happens in factorial, so if I will be passing 5 in it, in this function, so it should return 5 times 4 times 3 times 2 times 1. So 5 fours are 20, 23s are 60, and 62s are 120. So this means that if I pass in place of n, I will write 5. So what should happen? The answer must be 120. So there are many examples that we can solve, like we can start for I in range 1 to n plus 1, okay, and then what should happen? Answer is equal to answer multiply by I, and then we will print answer at the end. So in this case, what is happening? uh, Factorial, and here I should pass 5. So you guys can see that 120 is returned. So if I write factorial again and I write 4 over here, so the answer is 24. 4 times 3 is 12, 12 times 2 is 24. Same as if I call factorial and I will be writing, for example, 10. So hopefully it will be, for example, 6. So it will be giving us the answer 720. Yeah. So this is how factorial function works. Or we can do another thing that we can also implement it like this, that for example, if I comment this part and I write over here while I is greater than equal to 1. So what should we do? And here I should provide I is equal to n. So what we should do? Answer is equal to answer times n times I. And then we will decrement I is equal to I minus 1. So in this case also, this code will also run fine. Factorial, and here I should write 5. So you guys can see that 120 answer is returned or printed. But if we call this by the help of recursion, so the benefit is that we do not need to apply these loops. So, and if we discuss about the time complexity, so it is also less in the recursive functions. What we have to do is to write a recursive function for factorial. I discussed previously that we must know what is the base case. So for that, def factorial, and here we will pass n. So what happens? Like in factorial example, we are multiplying with the previous value, right? So we know that uh, the answer of 0 factorial is, or 1 factorial is basically 1, right? So I am writing that if, so the base case is, I should write hash base case is that if n equals to 0, we should return 1. We know the answer of 0 or 0 factorial, that is 1. Else, what we will do, else what we will do, we will just return, we will just return n times factorial n minus 1. Let me dry run this. What will happen? First n will be 5. Then what will happen later on? Like when I will pass n is equal to 5. So what will happen? N equal 0. This condition will not satisfy. The code will come over here. N is equal to 5. So 5 times factorial 5 minus 1, that is 4. So this time we will pass 4 in the factorial function. So now 4 is not equal to 0. Then we will come over here in the else condition again. And then we will do 4 multiplied by factorial. In the factorial function we will pass 3. Respectively, uh, afterwards, at the end, finally we will pass 0 in the recursive function, and we know that if we pass 0, we will get 1 as returned. So how I will be calling this? I will just write factorial, and here I will pass 5, and I will just print this. So here you go. Like we got the answer 120. How I wrote this factorial function, I know the base case. And then we just multiplied the answer we are getting with the previous one. Like n with previous value. Like 4 passed in the factorial function. Let me comment the dry running also so that it will be easier to understand. Like firstly, what will happen? It will be 5 times factorial 4. Then it will be 4 times factorial 3. Then it will be 3 times factorial 2. It will be 2 times factorial 1. Then 1 times factorial 0. And now know that the answer for factorial past 0 is 1. So 1 times 1 will be equal to 1. Here what will happen? It will be 2 times 1, that is equal to 2. Then here it will be 3 times. We know that the answer when we pass 2 in factorial function, the answer is 2. So 3 times 2 is 6, right? So now in this case, it will be 4 times 6. And so lastly, it will be 5 times 24. So the answer is 120. Let me take another function. So now we are going to discuss the another example, that is the Fibonacci series. This series comes up by or we can say Fibonacci sequence. What happens basically? We add previous two values to get the next value. Okay, this series starts from 0, then we have 1. Then if we add these two values 0 and 1, so we will get 1 again. Then if we add these two previous values, then we will get 2, right? If we add these two values again, then we will get 3, right? So this series usually starts from 0, and then we 0 and 1, and then we carry on to find the next upcoming numbers, like the next number will be 5, the next number will be 8, so on. If we try to illustrate that how we should write the recursive function, so basically what should be the recursive call? Recursively we will be going to add the previous two values, right? But for example, if I need the 15th term, so how would I know that what was the 14th and 13th term, right? So we will recursively go back to 0 and 1, right? Because we know that if in the first one, if we get 0, if we have the n 0, then we will return 0, and if the n is 1, so we will return 1. But afterwards we will be adding them. So now what we will do, we will define the function Fibonacci, and as I said that we know about 0 and 1, the first two values, right? So we will call the Fibonacci function, and here the base case is that if n is lesser than equal to 1, you just return n, just return n. And else what we will be doing, we will call the Fibonacci series, so that if we don't know what the value should be returned, we just know about 0 and 1. So in this case what we will do, we will call the Fibonacci function with n minus 1 plus Fibonacci function again, and we will call n minus 2. So here we will call return. So if we see, if I run this now, right, I didn't call the function. So if I will call Fibonacci 3 and I print the value, if I call the function by calling Fibonacci 3, so this will return 2. Let's say that I write 5 over here. So the fifth term is 3, 4, 5. It is 5. Let's say I write 6 over here. So it will return 8 as the answer. So this is how we can use the recursive function to find out the Fibonacci series. So following these examples, I hope you guys got the concept of what is a recursive function and how to implement it. What is a base case? Base case is what the answer that we know, and the recursive call is that how the previous values will be coming, right? So I hope that you guys got the concept for the recursive function. It is very important because whenever we go to the data structures, uh, it is very important to use. It makes the recursive calls, makes the flow of work very easy, even in the algorithms in AI, like we will discuss alpha beta pruning and min max algorithm. So recursive call is very important in those functions, in those algorithms also. So even in we will discuss some sorting algorithms like merge sort, quicksort. They are also using recursive functions. Why? Because they makes the work easy. They makes the work easy. We know what is the base case, and with the help of the base case, we basically have to approach the base case. What is approach? The approach is the return call, right? And in the factorial case, this is the return call. So I hope you guys got these concepts. See you guys until the next video. Take care. Goodbye.